All right, now once you find the LCD, what's the next thing you have to do?
Multiply everything by the LCD.
Okay, multiply both sides by the LCD, but what is it that you have to do?
You need to put each side in parentheses.
Very good.
Okay.
So since there's more than one term here, you're going to put that in parentheses. So I'm just going to go ahead and rewrite it. All right, so you can do like this. All right, so both sides have more than one term. So you're going to close that in parentheses. So remember, the directions will say as presented in class, right? Okay. So know what that means.
And that's just like your videos, right?
Yeah.
Okay. Because your videos are awesome.
All right. Well, thank you.
Quite awesome.
So then what's the next thing you need to do? Once you put that in parentheses, what is the next thing you got to do?
Place 30 on the outside.
Very good. So see, if you can do that, you can do the test 1 equations. Because test 1 has no fractions on it.
Thank you.
Well, you better thank me for test 2 too now.
Do you still have the study guide for test 1?
No, you got to print it.
Yeah. Okay.
Okay. Now, once you put 30 in front of those parentheses, what is the next step?
You're going to
Distribute. All right. So you're going to say 30 times a fifth x plus 30 times 2/3 plus 30 times 2x plus 30 times the negative 1/2. Now, what's the purpose of multiplying every term by 30? What does that do?
get rid of the fraction.
All right. You see, you've been studying. Very good. All right. Well, I'm very proud of you.
That was me.
I know. I know. I have my glasses off, but I can still kind of tell where it's coming from. So what is 30 times a fifth, though?
6.
6. So 30 times a fifth is 6. So what's 30 times a fifth x? 6x. Plus, what is 30 times 2/3? 30 times 2/3. You can say 30 times 2 is 60 and 60 divided by 3. Or you can reduce first. Remember, the whole point of multiplying by the LCD is to get this denominator to be a 1. 3 into 3 is 1. 3 into 30 is 10. 10 times 2 is 20. That's plus 20. Equal. And then, what is 30 times 2x?
Wait, I'm sorry. How do we get 20?
10 times 2 is 20. 3 into 3 is 1. 3 into 30 is 10. 10 times 2 is 20.
Okay.
Okay? All right, now, 30 times 2x
60x.
minus, what's 30 times a half? 15. Okay, so now that looks like something we've had from a previous section. So remember, everything we're doing in here are linear equations or linear inequalities. Next semester it's different. In college algebra is different. So let's, yes?
Why didn't we say that 2 goes into 2 one time and 2 goes into 30? How many times?
Because we all know that half of 30 is 15.
Oh, okay.
But you can do, I mean, if you want to, you can say 30 times a half. 2 into 2 is 1. 2 into 30 is 15. 15 times 1 is 15. Right?
Okay.
But half of 30, you know, is 15. It's okay for you to know it, but that's what you do.
I did, but I just...
You just didn't see it?
Yeah. I
That's
did not
okay.
see it.
That's all right. It happens.
Because I got the right answer, but
Yeah.
because of my calculator. So I already had it written down.
And try not to rely too much on a calculator. You got to
So
think,
that's why I wanted
because it's
to
gonna.
know.
If you rely too much on your calculators, it may hurt you somewhat in college algebra.
Okay. Okay.
Okay. Now, what's the next step you're gonna do?
No.
Get the variables on one side.
All right. Which side you want to bring them on does not matter.
The left.
The left. All right. So that means I need to get rid of the 60x. So you're gonna add or subtract 60x. Subtract. Okay, now again, even though I mentioned it before, some of you still turning in worksheets where you just say subtract 60. I'm going to keep taking points away. You don't say subtract 60, you say what? subtract 60x, because subtracting 60 is mathematically incorrect here when you combine them, because 60x minus 60 is not 0. They're not like terms. 60x minus 60x is 0. Okay, so you need to make sure your statements are mathematically correct. All right, and remember, it's as presented in class, and some of you are, maybe not some of you, one or two of you are still wanting to do things your own way. All right, do things your own way, and I'll keep taking points away. All right. So when I combine like terms, what's 6x minus 60x? Not quite. Negative 54x plus 20.
It was a bug.
Oh, I thought
Big
she,
bug.
I
Really big
thought I had to call 911.
Not used to this.
Minus 15, right? I was a little worried there, girl.
That's very lovely.
What's the next step?
Move it, subtract 20.
All right, so I'm glad you changed the word move to subtract 20 from both sides. All right, subtract 20. Combine like terms. Now, when I did the subtract 60 from both sides and subtract 20 from both sides, what property am I using? All right. Okay. Combine like terms. I'm left with negative 54x is equal to negative 35, right?
Yes.
All right. What's the next step?
Divide both sides by negative 54.
Right. Now negative 54x, negative 54. Because look, if you divide by negative 54x, let me just show you. First of all, divide by negative 54 is correct. You divide by the coefficient because you want a 1x, right?
Yes.
Negative 54 divided by itself is 1. 1 times x is x. That's what you wanted. A negative divided by negative is a positive. Can I reduce 34 54ths?
No.
No. So there's your answer. All right, now, just to remind you, do not divide, only divide by the coefficient. Like this. So when some of you do this, all right, when some of you do this, you're saying x equals, you're giving the right solution, but mathematically this is not correct because negative 54x divided by negative 54x is not x. What's negative 54x divided by negative 54x? 1. Anything divided by itself is 1. And you're saying that 1 equals a negative, and negative is a what? Positive. So you're saying that 1 equals 35 over 54x. That's what you're saying. That's what this says. But have you gotten x by itself? No. All right. So that's what you're saying when you do this. So there's some misconception there, and if you don't correct it now, it's going to come back in later on in college algebra and hurt you. Okay, because you're not thinking, well, what does this step mean? You're just maybe something you've done so many times in the past that you think is correct, but it's not. Okay, so this is not, so don't do this.
I appreciate you going over that because that's that's where I mess up. I think about it right, but I'm putting that variable on the end, and you have to learn when to drop it.
You have to know how to write it. Yes, you have to know how to write those statements. Okay, and then one more from that section. So let's solve and let's say we had that's negative 2 x plus 1 over, and let's say this is 6. Let me go ahead and make it like this then. Let me just say negative 5. I'm sorry. Negative 5. Put that as negative 5.
The first step, LCD.
Okay. What I would have done first, though, I mean, yeah, you could do that. The first step, you can't do the LCD here, but I would have just gotten rid of the parentheses to begin with. Okay. Distributed property. So the numerator would have been, the first one would have been, that's 6. 6x minus 3 over 4 equal, over here, that would be minus 5 over 6, right? Okay. Now find the LCD. What's the LCD? 12. Now someone said 24. 24 is not the least, but it's a common. You can use a common denominator. So if you want to multiply both sides by 24, that's fine. If you want to multiply both sides by 48, that's fine. But always use the least common denominator. It makes things a lot simpler for you. So what's the least? You would have to reduce at some point. Yeah. But you'll still get the same answer in the end. So 12, right? So now, remember how we put, in the previous one, we put those in parentheses? I don't need to do that here because that's really just one fraction. At the beginning, I can think of this as one fraction. So I'm not going to put parentheses just yet. You're going to see why I'm probably going to do it, though. So I'm going to have 6x minus 3 over 4. I'm just rewriting this. I'm going to say times 12 times 12, right? Now remember, the whole purpose of multiplying by the LCD is to get what number in this denominator? A 1. So 4 into 4 is 1. 4 into 12 is 3. 6 into 6 is 1. 6 into 12 is 2. Now, here's why you may want to put parentheses around the numerator, because if you're not thinking correctly, you're going to say 3 times 6x is 18x and say that this is 18x minus 3, and it's not. It's 18x minus 9. So put that in parentheses here. Put that in parentheses here. And now you have to do the distributive property again. Distributive property again. So on that number 4, on that worksheet that's due next class period, that's the one that's 9.3b. Looks just like that. So you want to do it like this. So what's going to be the left-hand side expression?
18x minus 9.
What's going to be the right side? Negative 10x minus 10?
Minus 10.
Okay. All right, and now that kind of looks like something we've done in a previous chapter. So you want to bring the variables to the right or the left?
To the left.
To the left? So I'm going to, is adding 10x or subtracting 10x going to help? Adding 10x is going to help. Now notice I'm saying 10x, not plus 10.
Why would we not subtract that?
Subtract 10x? Because it's not going to help. I mean, you can subtract 10x
Wait, did you write your negative sign by your 10x?
right here.
Okay, it's so far above. I missed it.
Right, I know, it is.
Okay, sorry
Okay.
about that.
But you know it's going to add, right?
Yes, sir.
Okay. All right. 18x plus 10x is
28x.
28x. I got 28x minus 9 equal negative 10, right? Because negative 10x and 10x is 0. That's what you wanted there.
Mhm.
2 more steps and you're done. What's the next step?
Add
9
9
to
to
both
both
sides.
sides.
Combine like terms. 28x equal negative 1. 1 more step when you're done. Divide both sides by 28. And so what's the solution? All right, so that's your solution. Okay, so that should help you somewhat on worksheet 9.3b.
What if on the worksheet, we went ahead and did everything in the parentheses?
That's fine. Okay, now, so we've been working on solving linear equations. Now we're going to look at solving linear inequalities. Linear inequalities. So one of the things you got to be able to do in solving linear inequalities is know how to write the solutions. So if you go back to those equations, the ones that we did, for the most part, there was only one solution, correct? There's only one solution, x equal whatever or y equals whatever number it is. Now there is one worksheet though that you're turning at some point in which you can have no solution or all real numbers. But for the most part, the linear equations had just one solution. If you look at this linear inequality, x is less than 3. Now this is not an equation, because an equation has what symbol in it? Equal sign. This is an inequality. An inequality has a symbol, has an inequality symbol. Less than. Now remember, some of you, when you were in here earlier today, you were getting your inequality symbols confused. This is what symbol? That's less than. This is less than or equal to, right? This is what? Greater than. And then this would be greater than or equal to. So those are inequality symbols. So this inequality right here says that my solutions, you're solving this inequality. So the solution would be any number that makes it true, just like the solution would be any number that makes these equations true. For the most part, there was just one number that made the equation true. How many numbers make this inequality a true statement?
1 and 2.
Only 1 and 2 make that a true statement. So I agree, 1 is less than 3. That's a true statement. 2 is less than 3. That is a true statement. But is her statement correct? No. There's an infinite number of solutions. Is negative 5 a solution?
Yeah.
Yes, because negative 5 is less than 3. Is negative 2.7 a solution? Yeah, so it's not just integers. It could be decimals, it could be rational numbers, irrational numbers. Is negative pi, you had pi in high school geometry, 3 is approximately equal to 3.14. It's approximately equal to 3.14. It's an irrational number. But is negative pi a solution? Yes. Is pi a solution? No. Pi is not a solution. Negative pi is, but pi is not. Yes. This is section 9.7. So when you graph it, though, and on that video, now the video covered most of it, but some things apparently I didn't put on there, and I forgot that I didn't do that. But on the number line, if this is 0 right here, where's 3 located? To the right. So let's say this is 3. Notice there's no equal sign. So on my math lab, they use closed circles and parentheses, open circles on my math lab. So, and in your textbook, you're going to see open circles and closed circles. In some textbook, it's parentheses and brackets. It doesn't matter which one you use, but just keep in mind that on my math lab, you're going to have to use, when graphing, parentheses and circles. Excuse me. That's right. Thank you. All right. So since there's no equal sign here, on 3, is that going to be closed or open? Open. And make sure I can tell on your worksheet or in the test if it's an open or closed circle. If I can tell, I'm going to assume it's not correct. All right, so make sure I can tell. So if you need to make it a little bit big like I just did, make it a little bit big. So that looks like an open circle, right? Mm-hmm. There's no question that looks like an open circle. And I want to graph all the solutions that are less than or greater than. Where are the numbers less than that? To the left or the right? To the left. And so you're going to shade in like this, and you're going to use an arrow just like this, indicating you're going towards the idea of negative infinity. All right, so that's the graph. That's the graph of this inequality. Interval notation, when you write something interval notation, you write it from left to right, from small to large. So as I look at the graph is pointing to the left, right? Yeah. And this is pointing towards what concept? Infinity. Not infinity. Negative infinity. Infinity is this way. Negative infinity is this way. Think of these numbers. These numbers are more negative, right? Yeah. These numbers are more what? Positive. Whenever you write an inequality, infinity, negative infinity always uses parentheses, regardless. It's always going to be parentheses, because infinity, negative infinity is not a number. It's just a concept. So you're going to say parentheses, negative infinity, and make sure your infinity looks like an infinity symbol. Comma, all the way to what number? 3. I cannot use 3 because 3 is not a solution. Is 3 less than 3? No. So that's why it's an open circle. 3 is not less than 3, right? Okay. 3 equals 3. So since there's no equal sign, you're going to use parentheses. All right. So there's your interval. So this is interval notation right here.
Is that negative 0, 0, comma?
That's negative infinity. Negative infinity. It's a sideways 8.
Oh, okay. I knew that.
Yeah, don't put 0, 0. You're going to be upset.
Right. You gotta do that.
You have to know what infinity looks like.
Got it. Well, I can admit this one.
All right, now, if you had this, y is greater than or equal to negative 2, and I ask you to tell me what the solutions are. How many solutions are there? Don't say 2 again. You better not say 2 again.
Negative.
You better say how many. An infinite number. There's an infinite number. There are infinite numbers that are bigger than or equal to negative 2, right?
Right.
Okay. Now remember, when we did the equations, did we ever graph the solution on the equations? No, because there's how many solutions were there? Just one. So you just say what it was. Here, how many solutions are there? An infinite number, so you can't list them. So what you have to do is what? Graph them. So anything graphed is a solution. That's what that means. So these are all your solutions. How many are there? An infinite number. Okay? So here, I want to graph the solution. So I'm going to, here 0, negative 2 is on which side? The left. Is negative 2 a solution? Yes. Because is negative 2 greater than or equal to a negative 2? Yes, it's equal to. All right, now, since there's an equal sign, and since that means that negative 2 is going to be a solution, I'm going to put a closed circle on negative 2. And I want to shade in every number that's bigger than or equal to negative 2. So that means which way?
To the right.
To the right. So you do something like this. Make sure I can, like, there's some of you that like to write light, and I can't tell what your solution is. I can't tell. I'm going to assume it's incorrect, okay? All right, and then what would the inequality? Remember, the interval. Interval notation, you read from left to right. You go from small to large. So as I go from left to right, where does my solution start? Negative 2. Bracket or parentheses? Bracket. So bracket negative 2, comma, all the way to what? Infinity. And remember, infinity, negative infinity, you're always going to use parentheses. So there's your interval notation. All right. And then there are going to be situations where your inequality is going to look like this. All right, so the way you read this is that all of your x's, all your solutions are between negative 2 and 7. Not including negative 2, but including 7. And the reason I'm using the word not include is because there's no equal sign here. The reason I'm using the word included is because there is an equal sign here. So in other words, is 6 a solution? Is 6 a solution? Yes, because 6 is bigger than negative 2, and it's also less than or equal to what? 7. Is 8 a solution? No, 8's right here, right? So even though 8's bigger than negative 2, what's the issue? It's not less than or equal to 7. But here's the next question, though, just like we had here. How many solutions does this inequality have?
All the numbers from negative 2 and 7.
That's not, you got to tell me how many. An infinite number.
What?
There's an infinite number. Huh?
No.
But because it's not equal to -2.
No? Okay, so you see, some of you don't quite understand what numbers are. Usually for many students, they seem to think that it's only an infinite number if you have an arrow. That's not true. So I want you to notice this. How many numbers, now when I say the word number, I don't mean whole numbers or integers. I mean like decimals as well. How many decimals are there between -2 and 7, do you think?
Infinite.
There's an infinite number. Like, for example, 2.7, right? 2.7005, 2.700008. So you keep adding a bunch of zeros. You can add infinite number of zeros. So there's an infinite number here. Can I list them? Can you list the solutions? No. You have to do what? Graph it. All right. So at -2, is that parentheses? I'm sorry, is that we use open circle or closed circle? Is that open circle or closed circle? Here? And I shade everything between. Okay?
Okay, this may sound crazy. Do you mind going over the open and closed circle?
Open circle, no parentheses, no equal sign. Closed circle, equal sign.
Open, no,
So you don't need to draw an arrow.
No, because it doesn't. You're saying all the solution between these two numbers only. So no arrows. Her question was no arrows.
so the open
Okay.
circle is what? I'm sorry.
Open circle, no equal sign. Closed circle, equal sign. Okay? Okay, now. You're welcome. So what if you had this? Suppose I gave you this graph.
I'm sorry, so with the thing that you just, we wrapped in between, there would be no interval notation here?
Oh, you can put an interval, yes. Yeah, I'm glad you mentioned that. So the interval notation would be from parentheses -2 comma all the way what? No, it stops at 7. 7 with a bracket. So there's no infinity here. The only time you have an infinity is if you have a what? An arrow pointing to the right. You have negative infinity if you have an arrow pointing to the left. There is no arrow here. Your solutions only go between -2 and what? 7.
So when the arrow is pointing to the left, that's infinity?
When the arrow is pointing to the left, it's negative infinity, just like the first example we did. When the arrow is pointing to the right, it's positive infinity, just like that second example we did.
It's gonna be on test 2.
Yes, it's going to be on test 2. Okay, so let's suppose I had this graph right here. And so I want you to state the interval notation. So from the graph, it's easy to come up with the interval notation. You can read a graph from left to right. So where does this graph start? -3. Parentheses, because there's no, it's not closed. There's no equal sign. All the way to what? 5 with a bracket. So there's your interval notation. Whenever there's no infinity, whenever it's bounded between two numbers, your inequality notation, so state the inequality notation, so the inequality notation is where you have that inequality symbol in it. So with the inequality notation, see there's no infinity, negative infinity, so it's going to look like this right here. So this says that all my x's are between what two numbers? -3 and 5. All right, so this is what you're saying, though. You're saying that -3 is the smallest, right? So you're going to say that's going to be less than, not less than equal to, only less than because of the open circle. X, and that's going to be less than or equal to 5, less than equal to because of the 5, which has what kind of circle? Close. Notice the inequality symbols always point in the same direction. Less than, less than. So -3 is less than x, and at the same time, x has to be less than or equal to what? 5. Kind of makes sense. Negative 3 is the smallest. So negative 3 has to be less than all of these numbers, and all these numbers have to be less than or equal to what? 5. Okay? That's inequality notation because it has what symbol in it? Inequality symbols. That's why it's called inequality notation.
And they're gonna always point in the same direction.
Yes. So this was greater than, this would be greater than. Okay? Now, there are going to be situations when you're going to solve an inequality where you are going to have the variable on the other side. So it's possible you can see this. So I'm going to say graph this inequality statement. So let's graph 3 is greater than x. So most times, though, actually, it is easier for a lot of students. Back there, y'all listening? Okay. It is easier if you're when solving a linear inequality if the variable's on the left. But there might be situations where you would end up with the variable on the right. So like this. So when I graph this, here's 0, here's 3. The easy part for you is to tell me whether it's an open or closed circle. Is it open or closed? Open because there's no equal sign. So I'm putting an open circle in 3. The hard part for some of you is you're going to draw the graph in the wrong direction because here's what you're saying. You see the word greater than, the symbol greater than, and you go to the right because you think greater than, but you're not reading the statement correctly. This says that 3 is bigger than any of your solutions, which also means that your solutions are less than what? 3. So that means that x is less than 3. So this means this. So if you want to put the variable on the left, then you're kind of going in the opposite direction that you would think of. So remember, this means that 3 is bigger than all of your solutions, which also means that your solutions are less than what? 3. So again, if you had not done that, and if you aren't really thinking about what that statement's indicating, and it happens, you got to be careful. You're gonna put open circle in 3 and you go to the right. Is the graph going to the right? No, the graph is going to the left. So this is your solution. What now? X is less than. Yes, x is less than. That's less than. Okay? So this says that 3 is greater than all of your solutions. Y'all can hear y'all back there laughing. Come on, guys.
Okay, that's interesting. I'm trying to
So do you
understand.
just read it backwards?
You read it backwards.
Oh,
So you're going backwards.
so just read the whole.
So do we read it backwards because the coefficient is first?
You mean the constants first?
Yes, yeah.
It doesn't matter. It does not matter whether you leave it like this, okay? If you leave it like that, just make sure you know how to graph it. So the problem is that people see the greater than and they want to draw the graph to the right because they think greater than. That's not what this is. This says that your solutions are not greater than 3. Your solutions are less than 3. That's what that says. So
You want the variable on the left.
it doesn't matter. What I'm saying, it doesn't matter. What I'm saying is that for some students, listen to what I said at the beginning. For some students, when they solve an inequality and they write it like this, some students draw the graph incorrectly because they're not thinking about what this statement means. What they're looking at is the word greater than. And they think greater than means, well, I got to go to the right. But that statement, the variable's on the other side, so you got to be a little bit careful. This says that my solutions are all numbers that are less than 3. That's what this says right here. This says that 3 is the largest. So if 3 is the largest, then everything else has to be smaller than that. And it kind of makes sense because if I pick 2 and I put a 2 here, is 3 bigger than 2? Yes. Whereas if you had drawn this, and you can always check yourself, if you had said this was the answer, and remember that's incorrect though, and you check yourself, give me a number that's in here, give me a solution, 4. And let's think about it, is 3 bigger than 4? No. So you know that can't be right. So if you want to, if you leave it like this, always when you draw your solution as you think it is, always pick a number there and see if it works. All right, so just like I did. So I drew this, and I think, well, is 4 is in here. Let me check and see if it's correct. Is 3 bigger than 4? The answer is no, so you know it cannot be that. So it has to be this one. Okay, so as we go through some of this, though, we're gonna solve some inequalities where the variable is going to be on the other side, and we're gonna rewrite it to where it's going to be on the left side. All right, it's not difficult to do. So if you had this, oh, and by the way, what is the inequality symbol here? Inequality notation. So remember, when you read a graph, you go from left to right. So this is pointing towards what idea? Nope. Say it again. Negative infinity. So whenever you deal with infinity, negative infinity, you always use parentheses. So parentheses, negative infinity, comma, all the way to what number? 3 with a parentheses. So that's your that's your interval notation, right? This is your inequality notation. This is what? Interval notation. I meant interval notation. I'm sorry. Inequality notation is where you have the inequality symbol in it. All right. This is your inequality notation here. This is your graph. This is what notation? Interval. That's interval notation. So if I ask you to graph this, let's say it was this. Okay, now again, if you're not careful, and first of all, let me go ahead and put an equal sign here. Is there going to be a closed circle, open circle on -3? Closed. And if you're not careful, you're going to shade everything that's to the left because this says less than equal to, right? But remember, the variable is not on the left side. The variable's on the right, so you got to be careful. So if you did shade everything to the left, I'm not going to shade it. But if you did, let's think about this. Give me a number that's to the left of -3. -1's not to the left of -3. -4. -1's over here. All right. -5, -4. Is -3 less than or equal to a -4 or -5? No, -3 is bigger. So remember, the closer you get to 0, the bigger your negative numbers, right? Okay. So remember, though, this means right here, this means that x is what? Greater than or equal to a -3. So here's the graph. That's your graph. Now, once you got your graph, you can tell me the interval notation. You always go from left to right. So where do I start? With a bracket -3, comma, all the way to infinity with parentheses. So remember, infinity, negative infinity, you always use parentheses. Okay, so that was a quick review of what you had to do with sections A and B of 9.7. So that's not due until Thursday. Okay, now let's look at solving inequalities now with this. Okay, so this is going to be number
Let me ask you, before you move there, you say integral notation and then you say inequality notation. I'm not understanding.
inequality has an inequality symbol in it. Interval notation has parentheses and brackets. Interval notation. Okay?
No, okay.
Okay, well, let's do some problems and then hopefully it'll clear up.
Okay.
Okay.
Thank you.
You're welcome. Okay, so let's look at number 16. This is on page 700. So this is a very simple one. The one in your test will not be that simple. So you want to solve this inequality, right?
Yes.
And so just like an equation, you do it just like it were an equation. If this were an equation, how would you get the variable m by itself?
Add 3 to each side.
Add 3 to both sides. Nothing's different. You add 3 to both sides. And so you combine like terms. I'm still using the addition property of inequality now. Remember, this is not equality, this is inequality. So I'm using, this is now called the addition property of inequalities. Remember a while ago when we saw the equation, it was addition property of equality? Because we're dealing with equations. This is not an equation, this is an inequality, so we're dealing with the addition property of an inequality. It means the same thing as equality. What I add to one side, I add to the other. That's all that says. So when I combine like terms, what do I get on this side?
Is greater than 8.
Yeah, m is greater than 8. Okay? That is inequality notation. Why is this inequality notation? No. Because it has an inequality symbol. You have greater than. That's an inequality symbol. So this is inequality notation. It has an inequality symbol in it. So your solutions would be, so this is inequality notation when the variable is by itself. So you wrote an inequality notation. Now once it's in inequality notation, once you find your solutions, you can graph now. So let's graph. So here's 0, here's 8. Open or close circle? Open because there's no equal sign, meaning that 8 is not a solution. Because is 8 bigger than 8? No, 8's not bigger than 8. It's equal to. So that's an open circle. And this is an easy one because the variable's on your left. So that means that all my solutions are bigger than 8. So where do I shade? With an arrow. So there's your graph. Interval notation is where you have the parentheses and brackets. So when do interval notation, you read it from left to right. So as you go from left to right, where do I start? 8. But there's an open circle, so I use parentheses. So I go parentheses 8, comma, all the way to infinity with parentheses. So there's your interval notation. All right, so that was 16. Let's look at 20. Number 20, you have 7x plus 3 is less than 9x minus 3x. Yeah. Okay, so combine like terms first on the other side, on the right side. 9x minus 3x is 6x. So I have 7x plus 3 is less than 6x. Okay, so it doesn't matter. Now remember, this is inequality, right? It's very helpful if you bring the inequality to the left, and because of our discussion earlier. If you bring the inequality to the right, some of you may not think very like you should, and draw the graph in the wrong direction. So let's just bring it to the left. So that means you bring the variables to the left, the constants to the right. So she wants to subtract 3 from both sides. Is that correct? Can she do that at this point? Guys, can she do this at this point?
Yeah.
Why not? Yes, she can. Why do you say no? Tell me why you said no. Because it doesn't matter whether you bring the variables first or the constants first, right? We did that with equations. It did not matter. All right, so let's bring the variables to the left and the constants to the right. So let's subtract 3 from both sides first.
How do we do that? Because
You've done that before. Combine like terms, this is 0, right? So I get 7x is less than 6x minus 3.
But you're not combining like terms.
You're not combining like terms. You're just subtracting 3 from both sides. I can't combine like terms, so that's going to be 6x minus 3, right? Now you're going to do what to both sides? Subtract 6x. And now it's 7x minus 6x. positive x, 1x, right, is less than what? Negative 3. So there's your inequality notation. Inequality notation. Now, what does the graph look like? With what? Open circle. And their solutions are going which way? To the left with an arrow. What is the interval notation? You start from left to right. Parentheses. Very good. Negative infinity. Because the arrow is pointing towards negative infinity. Comma all the way to what number? Not 3. Negative 3 with a parentheses. We never said that. Wait, what numbers have a bracket? When there's an equal sign or a closed circle. That's an open circle. We never did say a negative automatically makes it closed circles or brackets. We never said that.
So when do we use the bracket?
When there's an equal sign or a closed circle. Okay. Now, before we look at the next one, let's review something else. If I have 5x, let me say solve 5x is less than 15, less than equal to 15. How do I get the variable by itself? Divide both sides by 5. Just like you would any equation, right? Divide both sides by 5. And so your solutions will be any number that's less than equal to what? 3. Now, what notation is this that I have right here? No. What notation is this? That's not interval. Inequality. That's inequality notation. What does the graph look like? Here's 0. Here's 3. Closed circle. Shading which way? Not to the right. To the left. This says x is less than or equal to. All right. What is the interval notation? Parentheses. Negative infinity, comma, all the way to 3 with bracket. So you go from small to large. It's got to look at this. If you say 3 to negative infinity, that's incorrect. You got to go from small to large. Negative infinity to 3. 3 is the largest. Okay, now what if you had this? Okay, so let's kind of review this. So we all know that 5 is less than 20, correct?
Yeah.
Okay, that's a true statement. And remember, the multiplication property of inequality kind of similar. Inequality is kind of similar to the multiplication property of equality. So if I divide or multiply one side by a number, I got to do the same thing with the other side, right? Same thing here. So if I divide this by 5, I got to do what? Divide that by 5. And I will end up with 1 is less than what? 4. Is that still a true statement? That's still a true statement. Okay? So, no, I'm just dividing, just to kind of discuss something a little while. If I have 5, it's less than 20. And this time, I'm going to rewrite it over. And this time, instead of dividing by 5, let's say divide by negative 5. Okay? Divide by negative 5. Now I have this. I have negative 1 right here, correct? And I have what right here? Negative 4. Is that still a less than statement? That's the question. No, it's not. Negative 1 is not less than negative 4. Negative 1 is what? Greater than. So here's what you got to remember now with inequalities. Whenever you divide or multiply, an inequality, and you only do that if you multiply or divide. If you add or subtract, the inequality symbol stays the same. when you divide or multiply an inequality by a negative number, you must reverse the inequality symbol. You must reverse the inequality symbol. Okay. Now, it's very easy for students to forget this, but once you go through more of your math courses, by the time you get to college algebra, you will remember this. You're going to make mistakes in here with this. Some of you will.
But we got a good teacher gonna make sure we get it right.
Well, depends on what you do. Your work habits outside of class matter. They do matter. All right. So when you multiply, divide, and inequality by a negative number, what must you do? Reverse. So less than becomes greater than. Greater than becomes less than. Okay. So you can see how it's going to work in a little while. So let's actually do one right now. So this is going to just be an example. All right, this is an example. Now watch the steps. It's not that difficult. It's fairly simple. So let's suppose, first of all, let's suppose we had this. We're going to do a simple one to begin with. We had 4x minus 3 is greater than or equal to, and let's say this is 5. I want to solve this inequality. I do it just like I would an equation. I'm using the same properties, except it's not properties of equality. These are properties of inequality. So you add 3 to both sides just like you would before. Nothing different. Combine like terms. Now remember though, if I ask you what property are you using here, don't say the addition property of equality. Is this the addition property of inequality? Yeah, because it's an inequality, right? So 4x is greater than or equal to 8. If this was an equation, how would you get the variable by itself? Divide both sides by 4. So I'm going to go ahead and rewrite this again. And then you simplify. So 4 into 4 is 1. 1 times x is? X is... No. Okay, so you see how she said you got to reverse it? No. The only time you reverse it if you multiply or divide by a negative number. I'm dividing by a positive number. You don't reverse. So this is x is what? Greater than or equal to 2. So your solutions are any number that's bigger than or equal to 2. So this is what notation right here, though? Inequality. So if I graph it, here's 0, here's 2, bracket R, closed circle R, open. Closed circle because of the equal sign, right? So closed circle means it's a solution. 2 is bigger than or equal to 2. All the solutions are which side? To the right. With the arrow, draw, make sure I can see that arrow. And then what's the interval notation? You start from left to right. Say it again. Bracket. 2, comma. Infinity with a parentheses. So there's your interval notation. All right, now let's look at this one. Suppose we had negative 4x minus 3 is greater than or equal to 5. So instead of 4x, let's make it negative 4x. See what happens. What's the first step? Add 3 to both sides. Combine like terms. Negative 4x is greater than or equal to a 8. What's the next step? Divide by negative 4. All right, now since I'm dividing by negative 4, and you don't have to do this, but if you're divided or multiplied by negative 4, I would circle the inequality symbol to remind you to reverse it. So negative 4 divided by negative 4 is what? It's 1. 1 times x is x. So my solutions are not greater than or equal to, my solutions are what? less than or equal to what number? Nope,
Negative
2.
two.
A positive 8 divided by negative 4 is a negative 2.
So why did you switch it?
Because I divided by a negative number. That was, did you write this down?
Yeah, I would, but I thought you meant something different when you said that. I thought, I didn't catch it when you said it.
Okay,
So you actually switch it before you wrap it.
yes. When you write the variable by itself, this better be the correct inequality symbol.
So I can't see if it, so it's x is
Less than or equal to negative 2.
And we reverse it when we do subtraction, and what was the other one?
Say it again?
We reverse it when we're doing subtraction.
No, you reverse it only if you multiply or divide by a negative number. We also made the statement that when you add or subtract, it stays the same. All right, so guys, I really need some of you to watch that video again that we're doing right now, okay? All right, make sure you do this. Make sure you watch it again.
A way for me to remember is whenever you divide fractions, you switch it to reciprocal. So you
What
do the
now?
opposite. Like my brain it's gonna remember it by whenever you divide fractions, you actually you flip it, right? You do the reciprocal. So this is basically flipping the thingy and doing it the opposite way.
No. Okay. So here's a, listen to me. Listen. If you're trying to memorize something without understanding, you can get yourself in a lot of trouble at some point. Okay? So let's actually do this then. Let's suppose I had 2/3 x is greater than 4. Okay? So you just make this statement that if I multiply both sides by the reciprocal, right?
No. I wasn't talking about using the reciprocal this way.
She just remembers in her head that you reverse it because when you're dividing,
You're actually-
you reverse. So it's just,
Well, but I could do that here. I'm dividing by 2/3.
she's trying to make it more.
But it's not correct. You're dividing by 2/3, right?
Yes.
So I'm going to multiply by the reciprocal, correct?
Yes.
Okay, so 2/3 divided by 2/3 is 1. Over here, this is 4 times what? 3 over 2, which becomes 6, correct?
Mhm.
Are you going to reverse this?
Well, no, because it's not a negative number.
But then why do you want to memorize that when you now know I only change the inequality symbol when I divide by a negative number or multiply by a negative number? Because that's the rule.
You only switch it whenever you're multiplying or dividing
By a negative number,
by a negative number.
yes.
Yes.
It has nothing to do with the. It has nothing to do with the reciprocal. It has nothing to do with that, because that multiplying by the reciprocal here, that number is a positive number.
Right.
It has nothing to do with that. It has to do with the fact that you're multiplying, dividing by a what? Negative number. Okay. So I need for you to get away from trying to memorize something in your head because it's not working for the most part. Okay, it really isn't. Okay, you got to understand.
Gotcha.
All right, and the part of understanding here was when we talked about this. That's where the understanding comes from. Okay, that's the understanding.
So why mathematically do we, I mean, I know you're saying that we do it, but what is the reason behind it?
When I divided, 5 is less than 20. You agree with that statement? When I divide by this -5, what is 5 divided by -5?
So basically it's not a true statement.
It's not a true statement. So to make it true, you got to reverse the inequality symbol. Okay. To make it true, you got to reverse the inequality symbol. All right. So make sure you look at this again when I post it. Okay. All right. Okay. All right. Now let's go back over here and graph this. Bracket or open or closed circle? Going which way? To the left. Now, remember, this right here is called the inequality notation. What would this is inequality. The interval notation will be what? -2 bracket. Yep, that's it. Okay. Now, one of the worksheets that I gave you last time. Now, if you weren't here last time, you got to get that from Canvas. But that was 9.2 part B. Let me see if any of you turned it in. No, 9.2, 9.7, excuse me. 9.7 part B. Any of you have it? Let me see 9.7 part B. Okay, so 9.7 part B, you can do these now. 4x is less than 8, you divide both sides by what? 4. Do you reverse the equality symbol? No, because I divided by a positive number. Here you get y by itself. Here you get x by itself. Here I'm dividing both sides by what? Do I have to reverse the equality symbol? Yes. Okay. All right. And then on the back part, we talked about this. So you got to go back to the beginning where we talked about this right here. Okay. All right. Okay, so all right, so let me do this.